Okay, welcome back, everybody, or welcome for good after the holiday. So in the O2O, I know everybody isn't here, but just to remind, we're working towards our exam on Wednesday. A light version of this, basically everything up to through the probability chapter. So we got to realize in this class, I mean, we're moving pretty quick because we're doubling up with the summer school times because we go 4 times a week instead of twice a week. And well, today is the last day to drop without getting a letter grade. Uh, so we're going to this week, and so after we get that exam, you're going to get released with that take-home test, and then you can work on it until I can't remember when the date time is, but I can adjust it to whenever you need it. But next week is really the end of class, so our exam is on Wednesday, July 18th, and that's not a regular class day. Now, I'm going to try to work out the exam so I can have it available during regular class time through that 5:30 time period, and I'm going to set it up like that, right from from the get-go. Because when I tried to change after the fact, with somebody coming in late, it didn't work. And we don't have any time after the exam. In other words, Thursday, there are no classes because Tuesday, right? Isn't that the 17th, Tuesday? I believe it is.
The 18th, the last day of class.
Okay, well, 17th to 16th will be the last day of class as far as the material and cover material. Then we'll have our class last test on Wednesday in class on the Zoom. And then this one will be set up, the exam, on the 18th. So Wednesday, the last day of class, and then we'll have review that day. So this is Tuesday then. Okay, just realize that. That's 1 week from tomorrow. And so in the meantime, you're also going to have this one out there, and you can work on it kind of as you please, as long as it's done by the date on it. Now it says due on 710. Does anybody know if it's open yet? Let me go ahead and check. I know I put it out there. And that take-home test is on the it's on the Newton, and you'll just be able to take it and work on it. You don't have to worry about Zoom in or the proctoring part. Let me just see what I got it set up. Okay, so it's open. You should be able to see it, and I got it on the 10th. I'll adjust that. We can have it at the end of the week if need be, but just realize that that's out there. And then next week, last week of class, a test in class and the exam. Thursday's not a regular class day, so that's why the time for the exam is listed as 5:30 to 7:30, because that's our exam time. But since we're not taking up a room, I think I can get up with away with opening it up early, like during the regular class time. Anybody have any questions? All right, we're finishing this baby up. We're gonna be done in about a week and a half by Thursday. All right, so the last thing we got to cover is chapter on statistics. And statistics is kind of what all this is being geared up for. And so let's just start looking at statistics and what it's all about. A lot of people might like to look at statistics as number crunching, and it is, because accuracy is important when it comes to any kind of math. So what we got to just make sure is we know the basics, what the terms mean. So when we read them, we know what they're asking for, or what the problem is asking for. And so let's look at just some of the definitions. Now, statistics is broken into two groups or two parts. The part that we're looking at is called descriptive statistics, meaning that we're just doing some basic calculations from data that we've collected and then organized it and given a report of basic calculations. Because those can tell us a lot. This is not within the scope of this class, inferential statistics, but that's where you draw judgments based on data. And the second half of Math 203, that's what it's about. Now, more importantly, there are these two different concepts in statistics. One is called a population, and a sample is a subset of that population. Now, what we are aiming to do with that sample, that subset, is that sample should be representative of the population. In other words, it's got to come as close as we can possibly get to having a smaller subset that mirrors the makeup of the population. I'll just kind of tell you about this thing, and it's built into our Constitution, but we have a what's called a census every 10 years. And that census is where the government goes out and finds everybody living in the country and collects certain information about them. It's very time intensive, and it takes a lot of time because you've got 230 million people that have to be contacted and get information from. It is not always something that's practical to do, because every 10 years, that's why we do it. So in the meantime, if we want to find out certain things or estimate that same kind of information, then how can we do it? Well, we use this thing called a random sample. A random sample is one that mirrors the population, and random is the key, because what we have to do is everybody that goes in our sample has to be selected without any kind of bias. It's very much like a lottery. If we found out that the reason a person won the lottery is because they were friends with somebody at the lottery company, or they knew somebody in government, or they were able to find some way to jimmy things so they could have a better probability, then we would rightly be upset. So that's what a representative sample does. Everybody in that sample has to have the same possibility of being chosen. We can't just leave somebody out because we don't like what they represent. There's different ways of doing it, but the goal is to have a random sample. There's systematic sampling. They don't mention too much about these that I saw in the thing, so I'm not going to get them too much, but you may see the terms used, some of these terms, so that's why I'm going over. But there's different kinds of sampling. The one that's most common, because it doesn't take very much work, is just convenient sampling. People just go out and try to do the best that they can with what they've got. But in reality, a sample or the collection of a sample needs to have a plan and one put in place so that we make sure that we have a sample that represents the population. Because it's a lot easier to work with a sample than it is with a population because it's smaller generally. All right, so here's where we're going to start getting into stuff that's kind of the meat of things. Because we want to actually know, how do we deal with this data when we get it? Okay. There's this thing called a frequency distribution that allows us to take just raw data and then organize it so that it makes a little bit more sense. If we just have a big glob of data, and this is like an example of what we call non-group data, because we don't have to do any of the grouping, it's already kind of grouped for us. Because if you notice, what this is, it's just the model number of some kind of a phone or something. A, B, C, D, and E. Okay, if the E had been an F, it could be like letter grades. So it's the same kind of idea. Each one of these values will fall into only one group, and they're self-grouped. Okay, they're already grouped by the nature of things, because we have here A. Is that all of the A's? So if it's all of the A's, then what goes in here would be a nice 3 to represent the 3 A's. So now, instead of having 3 A's running around in the wild, we have them over here, and we have them put into our frequency distribution so that we know at a glance that there are 3 A's. B, so 1, 2, 3, 4, 5, and 6. So 6. So that right there was just the box to put it. That's the way it looks in Alex. You won't have to do that. So I'll take that right and just write the number there. Now, anybody got any idea how many C's are there? Let's see. 1, 2, 3, 3. Looks like 4 C's. That's the one that's circled. Let's double back and see. Double back and see if we got any C's that are hiding in there. Nope. D's. 1, 2. And it looks like there are 3 D's, right? And then E's. 1, 2, 3, 4 E's. Now, if we've done everything correct, those numbers should add up to the total. And what is the total? Let's see. 1, 2, 3, 4, 5. And there's 1, 2, 3, 4 rows. So there's 20. So do those add up to 20? Yep. So I'm going to put the 20 here. So that shows that the total of all the values, all 20 values are in here. If it came out to 18 or 19 or even 20, then we obviously did something wrong. So we have to just make sure that we count every one of the items and record how many go inside of it. All right, any questions about how that works? The frequency distribution is a very important tool for statistics because, as I said, it allows us to be able to have a snapshot of the makeup of the data. In this case, it tells us how many A's, how many B's, how many C's, how many D's, and how many E's, rather than just having the big block of stuff. All right, now if data is grouped, in other words, we have to kind of establish some groups to put things into, then that's what this is about. We call the groups that we put the data in classes. In a sense, these up here were classes as well. It's just that they were already established for us. So when we have classes or numerical classes like this, then we have a whole range. Then that means then any number that starts at 66 and goes up to 71 will go inside of here. All right. So what I'm going to do is I'm going to go through here and I'm going to write over here a little tick mark for each one. So 67 would go in that one. 85 down there. 74 in there. 88 goes in there. 75 in there. 81 right in there. 79 in there too. 80 goes in there as well. 69. 82 in here. And 81. And 73 in there. So then let me go ahead and then kind of make this into a frequency table. So this right here would be our class. And then this over here is our frequency. All right, so this was 2, 3, 5, and 2, so that it adds up to 12. Let's just make sure that that's how many pieces of data we got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got them all. So what I'm going to do is I'm going to put those over here to just make it a formal table. So there's our frequency distribution. Very important tool in statistics. So there's our frequency distribution. So if we have that information, then we know quite a bit about the data, rather than if you just got a bunch of the piece of data. Now, these have all been rather small. The last one for the group data was, non-group data was 20, and this one's got 12 in it. Well, oftentimes data sets are larger than that, but not always. Now, one last thing that we might want to mention about frequency distributions is while we're here is this thing called a class width. Notice that this says the above has a class width of 6. Okay. So anybody have any questions about how we determine where each one of those values go at? All right, well, let me talk about this class width. Now, the class width okay. Now, when I say potential values, let me show you. So for this one right here, that's 66, 67, 68, 69, 70, and 71. 1, 2, 3, 4, 5, 6. Now, we got to watch out because we're used to, when we're counting, like if you like from 0 to 10, we know there's 10 values, but if you count 0, you have 11 because of the way that we count. So since we're counting the 66, it does a little bit of thing on your head because generally that's not the way we count. But there are six values in each class. Another way to determine those classes is to subtract, or no, I hate to use the word subtract, but it's the difference between any two classes. So if we take $72, and then we're going to subtract the one above it. See, we got 6. And we can do that with any of them. 78 minus 72, 6. 84 minus 78, 6. We can even do it on the other side, like say 89 minus 83. Any two, these are what we call the, this is the lower class limit, and this is the upper class limit. So any one. So you could take these two in the middle there, 83 minus 77. So class width is 6. That's what it means. It means that there are 6 values or 6 potential values in that class. Now, we only used 2 of them. We only had, what was it? 67 and 69. But there were a whole lot of other potential ones. There were 4 more, actually. All right. Does any of that pose any problems? Y'all okay with it? All right. So that's frequency distributions. A way to represent data without having to see every single value. Because just seeing a bunch of values is not necessarily going to be useful. All right. All right. So we got to realize that with certain kinds of statistical information that people present, they'll sometimes kind of fudge things to make them just look better. Like on this poll here, notice that these don't add up to 100%. So if everybody doesn't add up to 100%, something's not right. On this right here, they kind of make the scale where it's not even all the way across, so that this relationship right here, it makes it look like it's a more straight linear relationship. And that is one of the things they'll talk about over there. You can also exaggerate differences by taking your taking your y-axis and making the differences look stronger or larger. Like the difference between 35% and almost 40% is really just 5%, but it makes it look visually like it's a lot larger. Now, the misuse of graphics thing is something that everybody does. So, it's just the way human beings work. They have a message to present, so they have to present data to support it. So they take the data and visually distort it, let's say, to make it represent what they think it should say. So there's different kinds of graphs. The histogram is a bar graph that really is a graph of a frequency distribution, because a histogram has special rules to it for a graph. You can also do same kind of thing with a frequency polygon. But let's look at this thing called a stem and leaf chart first. These different types of graphs are not so important. The histogram is going to be the big daddy. But let's look at how a stem and leaf chart works. Now, stem and leaf chart is a way to take data that we have, and then instead of just knowing the number of values for each one of the ranges, we take and we keep each individual value so that it could be reconstituted if need be. Let me show you what I'm talking about. Stem and leaf. All right. All right, we got 20 different pieces of data here. It's from 20 days at an outpatient center where they do cardiograms. In each one of these 20 days, it tells us how many they did. So on this first day, they did 25. The second day, they did 31. Third day, 20, and so forth. Now here, they've kind of made this one friendly for us because we generally wouldn't put 0 to, we would just put a 2 there. But they want us to know for sure what the stem and the leaf is on this. The stem is the tenths. All right. So let's kind of go through here. Deal with this. I'm going to put it right here on the side. Make a little chart. So what I'm going to do is I'm going to put my stems here. Now the stem is the tenths. So the lowest one is a 0. We've got plenty of teen ones, 13 and 14 and such. So that would be a 1. We got 2s. See, 25, 20, 23. So we're going to put that there. We got some with 3s, 30s. And then 4. Let me fix something. I should have said. Because there's no decimal. If it went on the other side of the decimal, the first one is the tenths and the hundredths. So I just want to get that straight. Okay. And then up here. And there's our leaf. Now, what we're going to do is I'm going to go through each one and I'm going to find the proper place for it. So for this one, that would be in the 2. So in order to represent this 25, we would write a 5 here. So now we have 25. 25. All right, so this one is 31. So we're going to go down to the 3. And we're going to put our 1 there that represents that. Next one is 20. So that means then we're going to put a 0 there. So now we got 2 of them on that 2 row, the 20 row, or the column actually. So 25 and 20. We're not writing out the stem multiple times. We're just writing it once. And when I'm finished with this, we're going to have some information here that'll be useful. So we got that one. 32. 13 would go right here. 14, 43, and then there's that one right there, 02, 57, 23, 36, 32, 33, another 32, 44, another 32, and here's our 52, 44, 51, and then 45. All right. Now, the good thing about the stem and leaf is it gives us the same kind of information that a frequency distribution gives us, because if we kind of look here, we can see the pattern here. I'm going to try to draw a little shape here to show you, and this will help us as we get later on. All right. So if you kind of cock your head to the right, you can kind of see the shape of the data in the same way that the histogram, the frequency distribution told us the number of values. So see this one has 2, this one has, that's one value. 2, here's 3, 1, 2, 3, 4, 5, 6, 7, 4, and 3. And they all add up to, let's see, 1, 2, 3, 4. Should be 20. So there's 10, 10, 17. Okay, so yeah. So that's what we call a stem and leaf. All right, so I don't want to go on quite to this yet. So I'm just going to go and get some problems out of that textbook. So we can have some more to do. And then before we end, I'll talk about the mean, median, and the mode. Those are pretty easy things to know or do, actually, once you get the hang of it. All right. Up in the wrong one. Oh, I could go over there from here, yeah. Okay. So let me just kind of go through this with you about what I was trying to do on that second frequency distribution. But this is the kind of thing that I was showing you. The tally is not part of the frequency distribution, but it's a good way to do it because you have to account for every piece. And as you go through, you can do that by just keeping track. So like I said, yes, there's a 1 that goes right there. 2 goes right there. So that's how that frequency distribution works. I'm going to find us another one to do. And then that's why I generally use that, but it's not part of the frequency distribution. It's just a way to keep track. Oh, this is actually, well, let's go down to the problem sets and look for one. Now, the bad part about these is they don't tell you what class to use. And most everything that you're doing, it'll tell you what the classes are. So I'm going to make up the classes on these. Let's see. So this is a neat one here. The ages of the signers of the Declaration of Independence are shown here. All right. So we want to use 7 classes. So let's see. I'm going to find the highest one. Like I said, you don't have to worry about determining the classes. Looks like 50 is about. No, here's 63.
We got 70.
Yeah, 70. So what's the lowest one?
27.
41 is there. Is there anything low? Oh, wait a minute. Yeah, 27.
27.
Yeah. You think that's the lowest one? I think you got it.
There's two 27s, but yeah, those are the lowest ones.
As long as that's the lowest one, it doesn't matter about the number. What we want to do is just make sure that we start low enough to get all of them. So let me just show you, this is what I can do. You don't have to worry about this because, like I said, they usually give you the classes. So 70 minus 27, 43. So I'm gonna make my classes about 6 each. So I'm gonna start. Go over here where I can draw. All right. So I'm going to start the first one at 27. Like I said, this determining the classes is kind of a science in itself. It's not really that hard, but they're not going to tell you to determine the classes on any of the problems because there's no way they can grade that. So I'm just going to. All right. So we'll just start it at 27. All right. try that again. Okay, so it was 70 minus 27. They said they want 7 classes. All right, I'll tell you what I'm going to do. I'm going to start at 25. All right. They didn't tell us how what the size of the class needs to be, but I'm going to do 7. All right, so that means I'm going to have 25, 26, 27, 28, 29, 30, 31. So I think it should go out to 31. Which means the next one would start at 32. We don't want any holes. And so we'll notice at this point, once you determine the first one, it's easy. But I just made it 7. So now if you take 25, say 32, add 7 again, 39. And then this would be 45. And then I'm just going to keep on going until I get past 70. And then I think one more. 2 more. So then this one's going to be 60. There we go. So now there's our classes. So play like that's a given. If you don't understand how I created those, don't worry about it too much. So now I'm going to go through and then I'm just going to determine the frequency. So I can use the little tick marks if I want to, but you're not including that in your frequency distribution. So let's just go ahead and so 41 would go here. 54 here. 47 in there. 40 would go right there. 35 would go right there. $35. 50. 37. 70. So 32 right there. 44 completes out that one. 52. And then 39. 50. And then 40. 30 is going to be up there. 34 here. 69. There next to our 70-year-old guy, 39. 45. 33. 52. 44. 62. 60 goes in there as well. 27. 42. 34. 50. 42. 52. 38. 36 also goes in that same spot. And 45. 35. 43. 48. And then 46. 31. 27. 55. 63. 46. 33. 60. 35. 46. 45 also goes up here. 34. 53. 50. And there's two of those. All right. So we're using the tick marks to count them. Let's just make sure that they add up to they don't tell us how many there are, but let's count them. We can count them. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4. So that's 48, 49, 50, 51, 52, 53, 54, 55. So it should be 55. So let's look at it. So this one's 4. 10 and 2 is 12. That's right at 15. That's 14. 3, 5, and then 2. And then if we've done everything correctly, four plus 12 plus 15 plus 14 plus 3 plus 5 plus 2. All right, good. That's good news when the numbers match. So here is our frequency distribution. So the frequency distribution is this part right here. We use the tallies to help us keep count, but that's the frequency distribution. Now, The histogram is just a representation of that. Okay. Something just missing out of here. I don't know what it is. We'll just go ahead and do it over here. So what I want to do is I want to create a histogram out of this, because that's the third type of graph. You got the, and it's really the most important one. It's the frequency distribution graph called the histogram. And there's other types of graphs like pie charts and everything, but this is Big Daddy, the one that's important. All right. There's a neat little drawing tool in the Newton where you can just kind of take a dot and move it up, and that tells you where to put things. So it's not nearly all the trouble I'm showing you, but I'm going to go ahead and create a histogram. All right. And so what we have here, let's see, we got 1, 2, 3, 4, 5, 6, 7 classes. All right. They're more or less even, but anyway, hopefully you get the idea. All right. So then the way it works, it would be, 25 on that end to 31. This would be your midpoint. Oh, back up, back up, back up. 32. 39. 46. 53. 60. And then 67. All right. Now what I'm going to do is I'm going to create a bar. Well, let me put up here. My maximum frequency is 15. So let's just put a big 20 right there. And then half of that would be 10. All right, so let me put this in blue. So now my first graph, my first bar chart is going to be up to 4. So I'm going up to about right there, and then we're going to try to color it in as best as we can. Because it's a bar chart. So this one, next one would be 12. This one would be 15. So let's go ahead and do them all. In theory, like I said, I'm not doing too good of a job, but these all should be the same size. I've got it same size as far as the numbering is concerned, but my lousy drawing is making some of these look kind of different sizes. But And then this is the 14. And then this one, the 53 to 59 is 3. This one would be 5. I need one more. So this one would be the 73. So then here's our last one. Oops, this one was 2. So there's your histogram that represents that. And as I said, is all of these are technically colored in because it's a bar chart. And so what that does is it shows you the pattern of the data. So we gotta just imagine that this whole thing is colored in. And so looking at it lets us know a pattern of the data. The data starts out at 4, goes up to 12, 15, 14, 3, 5, and 2. So it shows us the shape of the data. And as we're going to see in the rest of the week, that data, by its very nature, a lot of data forms this pattern called a normal distribution. And this more or less does that because it goes up, starts out low, goes up, reaches a peak, and comes back down. So something like this would be symmetric and unimodal because there's really only one big peak at the top. All right, one more thing. Something like got taken out of my notes because I thought I had a thing in here to do. But that should work. Maybe I'll put it up here. Oh yeah, okay. I had done it right there, but that's the same kind of thing. Anyway. All right, that's probably enough for today. So tomorrow we'll get on the averages. So, or measures of central tendency, they call them. So there's 3 or 4 of them. Basically, the mean, and the mean is the one that most everybody knows. Yeah, I mean, yeah, there's stuff in there. I sent you an email about it through announcement through Canvas that there's certain ones I couldn't get them out of Canvas, but I don't know what it is, but they're not in the grade book. But yeah, there's stuff because you got to realize between now and next Tuesday, we're going to be testing on this. So look at that announcement because there's certain ones I said not to do. Because on my view, it still shows them up there, even though the date's changed. And like I said, I can't figure it out. So, but let me just talk about these to set us up for tomorrow. measures of central tendency. The first one is called the mean, and the mean is one that most everybody knows about. There's population mean versus sample mean. They're done exactly the same. The only thing that's different is there's generally a different symbol. So for the population, it's mu. It looks like that. It's a Greek symbol. And for sample, it's called X bar. And they're done exactly the same way. The way that we calculate the mean is to add up all of the pieces of the data and divide by the total number of pieces of data. I bet you most everybody in here has done that, because if you take 4 tests and you want to find the average, then you add up those 4 tests and divide by 4. Okay? So like on this one right here is, we would just do this. So the mean is equal to, and so it will be up here at the top, 5 plus 7 plus 10 plus 11. And then down here, so there's our fraction line. And then down here is 1, 2, 3, 4, 5, 6. So if we add all those at the top, 5 plus 7 plus 10 plus 11. So then that's 60 divided by 6 is equal to 10. So that's the basic calculation of the mean, the most important measure of central tendency. So that's all I'm going to hit today. So if you got any questions, stick around. I'll be here.
Thank you. Have a good day.
Okay, bye-bye.